Hello everyone, thank you for joining today's ECA Technical Tuesdays webinar. In this session we have ECA Technical Manager Chris Edwards, who will be leading you through the major changes that you need to understand when delivering emergency lighting. Next slide please. Throughout this webinar, we will have Gary Parker, who is ECA's Head of Technical Standards, who will be answering your questions. So if you please submit these via the Q&A tab, and he will answer those throughout. But if we do have some time at the end, we may answer some of these live. This session is being recorded and will be available to watch on ECA's podcasts and videos webpage. So do feel free to share this with your colleagues and refer to the content afterwards. You can also claim a professional development certificate for attending this session. Details of how to receive this will be shared at the end. Thank you, and over to you, Chris.
Thank you, Kat. Good afternoon, everybody, and welcome to our webinar. Okay, the objective of this afternoon, as you can see on the screen here, is to talk to you about emergency lighting. Now, this is the plan. There are three standards that I wish to cover off this afternoon. As you can see on the screen here, it's 1838, 5266 and 50172. Now, we are doing them in a specific order, and there is a theory behind that. And the reason we're doing it this way is because, generally speaking, they all have a bit of a flavour that they offer. Specifically, the changes in 1838 is more to do with design. We're talking about the siting of luminaires, points of emphasis, specific areas, illuminance levels to consider, that sort of thing. So I thought that sits better at the front. And then after that, we're going to look at 5266, which brings to the party cable types, installation requirements, cable support, the use of trunking, that type of thing. And then at the end, or the last of the three, is going to be 50172, of course, which generally brings to the party handover documentation, details of initial verification, testing, and all that sort of thing. So that's the rough plan. Of course, there are huge areas of crossover between these documents. There are many repetitions of detail, but what I've tried to do with regard to this presentation is keep the areas specific to each individual document. In other words, if they bring a particular item to the party, I'm going to mention it in the changes to that document, and then I won't therefore repeat the information just because it's in one of the others too. So I've tried to keep it specific and apportion it where I think it sits best. These are obviously very closely related. 5266 is considered to be the base document, and the other two are considered to be the supporting standards. Now, just before we actually talk about these documents, I thought it may be fairly useful to talk about the legal trail, because sometimes this is an area of uncertainty. So I just wish to cover this off. Obviously, emergency lighting is a legal requirement. There's absolutely no doubt about that. And it's the fire safety order which starts the ball rolling with regard to this. And as you can see on the screen, it requires emergency exits and routes to be illuminated for safe evacuation, of course. But this may be a little bit of a surprise. It's also in here. This is another statutory document. Both are statutory documents, of course, i.e. law. And within the workplace regulations, we have this section 8 and it's indent 3 there. I refer you to, and specifically the second line down, which I'm hoping you can see. Emergency lighting shall be provided. So those two are statutory documents. But we've also, of course, got approved document B. Approved document is a guidance note, effectively, which informs readers of how you can meet the requirements of the building regulations. The building regulations, of course, is another statutory requirement. And with regard to approved document B, it refers back to a particular part of the building regulations. Now, within document B, there's this useful table which identifies where you would need emergency escape lighting. I'm not going to go through that. I'm just going to signpost it for you. Table 5.1 if you're interested. Of course, within approved document B, we do have that escape routes need to be adequately lit. And there's a really useful signpost there within that document too, straight to 5266 is saying, look, okay, we're a guidance document, but if you really want to know all the technical intent, go to 5266. So there's a sort of well, it's not even that tentative, is it? There's a link from legislation through an approved document to the British standard. And incidentally, within the forward of the British standard, it also then refers out to the other two, which sort of quite nicely completes the loop. Now, the intent of today, obviously, we're going to be talking about these standards. There's loads and loads of detail to cover, and I can't possibly hope to go into all of it in massive detail. But what I am hoping to achieve is just to signpost, pick out some pertinent points for you, and signpost you to where you can find the details. But going back to the law, there's a very key element here that I wish to relay, and this is all to do with responsibility, because I feel sometimes that our clients wish to sort of offload that onto us when we're providing a role or a task for them. But it's this one again that starts the ball rolling. It's the Fire Safety Order 2002, which is a key piece of legislation that firstly identifies what a responsible person is with regard to this requirement. And it's quite clear in there. Section 3 or item 3 details who the responsible person is. In other words, who's responsible for meeting the requirements of the fire safety order. There is a clear indication of the responsible person's duties, and I'm hoping you can see that just very briefly. That's indent 5. And their duties are significant. All the way through the fire safety order from Articles 8 to 22, they need to ensure that their duty is adhered to. And of course, another pointer again, that emergency routes and exits required illumination from emergency lighting in the fire safety order. And finally, just before we move on, it is the client, it is the duty holder's responsibility to perform a risk assessment. Now, more and more, as you see when we go through these documents, this is a very common message about the risk assessment. They're really trying to hammer home this point. It's like, look, it is legal duty that a risk assessment needs to be performed on these premises. The risk assessment will detail or ought to detail elements of fire safety, and which could include emergency lighting, but it's not our responsibility to do that. It is clearly the responsibility of the responsible person. That could be us if we're being employed by the client to do that, but ultimately in law, it sits with them. It's their requirement to meet these items in law. Okay, and finally, before we move on, sometimes I thought when I was looking through these documents, I thought, oh, the terminology can get a little bit confusing, particularly with emergency escape lighting and emergency escape route lighting. And I just wish to highlight that there is a difference. Sometimes the standards aren't brilliant because they sort of intersperse the two, and sometimes it's not always that clear, but this is the intent here. Emergency escape lighting encompasses 3 elements of route lighting, open area, and high-risk task. Emergency lighting per se also encompasses other areas too, which we'll look at shortly, but emergency escape lighting is not necessarily the same as emergency escape route lighting. The emergency escape route is, as you can see here, the defined area used to evacuate in the case of an emergency to a place of safety. Sorry, not the defined area, the defined route from A to B. You're going to walk along a corridor, for instance. That would be your escape route. Okay. So emergency lighting, it's a bit of a weird one, really. It's one of those things that many people don't really think about. It's a bit like your airbag on your car. It's one of those things that you sort of know is there, and in the event of an emergency, you need it. But other than that, you don't really worry about it. But it is a life safety system, and just to sort of set the tone, really. If I can give you this visual representation and with a link to some real incidents. So imagine you're in a hotel, it's 3 a.m. and this is your generic hotel corridor, and suddenly, for whatever reason, the lights go out or there's a power cut, but thankfully emergency lighting is there and it kicks in. You can make your way safely to a point of exit. Indeed, if there's a little bit of a fire and there's plenty of people starting to make their way down the corridor, again, generally, you should be fine in that situation. You will make your way out. But what happens if there's no emergency lighting? Well, I've highlighted these two scenarios. Both were tragic. Grenfell, of course, needs no introduction, but if you're as old as me, you may remember the Falklands War and Sir Galahad there. With Grenfell, it was indicated in the report afterwards that there were elements that were faulty with the emergency lighting, which may have contributed to some of their deaths, or certainly would have made exit not as easy as it possibly ought to have been. And I was privy to a keynote speech the other day by Simon Weston, who was one of the chaps on the Sir Galahad, unfortunately for him, who got terribly burned. And he was saying that during that incident where the bomb fell on the ship, all the lights went out. So there was no emergency lighting, no nothing. And of course, they were below decks, and it made it significantly harder to get out. So it's just to reiterate the point, really. You know, it's one of those things that we take for granted, but it is a life safety system. Okay, without further ado, 1838. 1838, recently updated, 31st of December. Incidentally, for your information, we do have more detailed guidance notes on our members or within our members area for all of our members to download should they wish. And that's the case with all of these documents now too. But 1838, recently updated, and significant changes, as is the case for all of these documents that we're going to look at today. The previous version was 2013, had 20 pages. The 2024 version has 36 pages. And I'm going to try and hit on the pertinent changes or signpost you where you can find the detail. Now, if I could give you a visual demonstration of the overall changes throughout all of these documents and really the intent by or behind these changes, it would be this. This was the old table 2 in the old version of 1838, and it's just a very basic block diagram trying to give you an indication of where the elements of emergency lighting sit. That's been ripped out and replaced with this. Now, this is straight away gives you much more detail. In the line 1, you've got the same sort of information, but what I really like about this, we've got all the other detail about where you can find the information in the documents. You know, clause 5.1, 5.2, for instance, is followed up by the minimum illuminance requirements, as well as activation time, rated duration, points of emphasis. And this is the point. This is what they've tried to do with the update on these documents, is to give you much better information, try and clarify the information, give it to you in an easily readable format. This is another generic point, again, not necessarily specific to 1838, it's across all of them, with the point, and they're hammering home this point all the time, that periodic maintenance and measurements with regard to verification are required, because there's a recognition, of course, with emergency lighting, like all systems really, but you know, batteries decline over time. The installation conditions could mean that the luminaires become dirtier and dirtier over time, particularly if there's no maintenance, and therefore when you need them to operate, either the battery isn't going to last for as long as it ought to, it may not have the same output as it once was designed for, or indeed the light is so filthy that it's offering no light for you to get out or see where you're going. It's those sort of things. So there's recognition throughout all of these. Actually, we really need to make sure these emergency lighting systems do what they do when we need them. Excuse me. Right, first up then, points of emphasis, sorry. Now, just to sort of give you a bit of a flavour before we go into any other changes, this again is indicative of what I'm talking about. You know, the old writing is in blue, and then the additional clarity, as it were, is in red. So just some generic pointers, and again to give you a bit of a flavor with how the points of emphasis have changed for better clarity. Dee and I were already there, but now we've just got some more info. This aspect is new though. So firefighting equipment was considered to be a point of emphasis, but they've now expanded that to encompass escape route plans or rescue plans. In other words, if firefighters, when they're coming into the premises, need to see where the layout of the floor, or indeed if you need to see the layout to get out, it needs to be lit in the event of an emergency. These are new though. And they're all to do with lifts or lift cars. Point J, it is now a point of emphasis near the point where an alarm call is received from a passenger lift car and the associated lift escape windings. And K, corridors from all passenger lift doors to the nearest escape route. So that sort of makes sense, doesn't it? You're going to come out of a lift in the event of an emergency and you need to see where you're going. This one too has been added, and this is not uncommon. You know, keypads to go through exit or entry doors, or to try and restrict access to certain areas. You need them lit. If you need to get through the door and in an emergency, you need to make sure that there's some light on the keypad so you can see what you're doing to get through. Section 5.1.1, escape route lighting. This is in all three documents, and hopefully doesn't come as a surprise to you. Historically, of course, what we've always done for our escape routes is measured the center line, and that was all we were required to do. Now that is expanded to cover the horizontal width, the width of the entire escape floor. It needs to be lit to that level. Borders are excluded. It depends how wide that corridor is. If it's over 2 meters wide, it's a different requirement to if it's under 2 meters wide. But the borders are excluded. Section 5.1.1, and it's just to cover the whole width now, and it's important we understand that, of the escape route, not just the center line, which we're all used to. This is a new bit. This is to do with, again, escape route lighting. So the scenario that we've just looked at, walking along the corridor, for instance. This now informs us that each part of the escape route must be lit by at least 2 luminaires. Now, this is to cover us for in the event of redundancy, I suppose, or fault. In the event of one light doesn't work in our emergency situation, we don't want that whole emergency exit to be deemed useless just because there's a failure on one element. So to cover that, it is now a requirement for 2 or more luminaires to light every section of an emergency escape route. These are new. And they've been introduced to this standard for the first time. These are adaptive emergency escape lights, and they have the ability to do exactly this. In normal operation, if the escape light is fine, or the escape route is fine, they would light up, as you can see, just the green. But if for whatever reason there is a problem with that area, then it will highlight that you can't go down that route and you ought to go a different route. Hence adaptive, normally linked in with the building management system or something, or certainly the fire alarm, that sort of thing. But this counts as your additional luminaire should you have one of those. Okay, open area, otherwise known as anti-panic lighting. Now this would be your classic example. We've got a generic open area office, as you can see on the screen here. And the new requirement now is that if we have a clearly defined escape route through that area, then it needs to be lit as per an escape route. Now, in this scenario, of course, we may have more than one, because the requirement in this document is that it is the shortest obvious route through that area. But in this situation, there's more than one route, and therefore it might be applicable that you light the whole area as an escape route, of course. Open area is generically half a lux. Escape route lighting would be 1 lux. But that's down to the design and down to the risk assessment when you're looking through these items. Incidentally, if there is just one route through this area and you do decide to deem that as a defined escape route, it needs to be a minimum of 2 width wide. And of course, again, the same principle that we've just seen, 1 lux across the whole width, the 2 meter, of course, is the requirement for the illuminance. Now there is a new section here, requirements for specific areas. And when I'm talking about specific areas, it's not points of emphasis, but something separate entirely, as highlighted as specific areas that we may need to consider separately because of the scenario, obviously. Now, this is going to be very much a signpost in here. It's section 5.4. They include toilet facilities and changing rooms, toilet lobbies, swimming pools, and single occupancy changing rooms with baby changing facilities. All of those got a specific requirements. Some are 1 lux, some are 5 lux. But this is the one that I do wish to highlight to you and will probably affect most of us. For the first time, we're seeing switchboards mentioned as a specific area requiring emergency lighting. Now, it is switchboards. There are 2 caveats to this. Switchboards only in motor generator rooms, control rooms, switch rooms, or plant rooms, and only those switchboards associated with normal or escape lighting meet this requirement. It's not to say that you can't encompass others, but that again, that's down to the risk assessment, the person undertaking the risk assessment as you wish. Now, quite often when we've been talking about this, we think, well, what about switchboards or fuse boards or panels in riser cupboards, that sort of thing? No, not necessarily covered unless they meet the requirement of a plant room, which they wouldn't normally. But again, those sort of things are to be identified within the risk assessment, and only those switchboards associated with normal and escape lighting. So if they're not associated with that, no requirement, unless you want to, of course. This is something that is new. It's something called local area lighting, and we're going to look at it in a little bit more detail, but just to sort of highlight it now as we're going through the section by section, local area lighting is new. It's a facility to identify a particular area within a building for which you may have additional requirements, and we will cover this a little bit later on. Whatever the situation, it's identified in the risk assessment and it needs to meet the minimum of 1 lux. Okay, on to Annex A. Now, all of the annexes really have been substantially rewritten. And this is really quite nice, actually. This has been rewritten, repurposed. But now we've got a really, really nice table. And it's a bit like exactly that example that I shared at the front of the document. Within Annex A, system durations and activations times, a really helpful table, which just gives you the information that you're looking for in one specific point. And there is, again, as always, there is a caveat with this. If no national conditions apply, then follow the guidance in this table, but the national conditions may top trump this. But don't forget, these guidance are all documents. These documents are all guidance. There may be additional requirements that would supersede these, but if there isn't, then the recommendation is to follow these documents. Annex B. Annex B covers a huge amount of detail about the sort of equipment that you can use. But if you have these documents, you will see that a lot of these annexes are common to certainly 2 of the documents, and this would be a classic case. So I just want to signpost that I am aware of Annex B, obviously, but the detail is going to be covered in this aspect of 50172 a little bit later on. Annex C is new, and it covers the new addition, which is local area lighting. Now, this gives you a lot more detail here. It tries to caveat what it is, when you would use it, and some options for consideration to the designer if you are considering having an area designated a local area, or that certainly needs local area lighting. Now, there are 4 options. which we're just going to very quickly cover off here. So don't forget, these are specific areas within a building that may have different requirements to the rest of the building. So therefore, a typical example, which is funny enough, example D, is where, say, for instance, you've got a staff room and people are allowed to stay in that defined area for longer because it's safe to do so. They can perform their normal tasks within that area, but the rest of the building has just the normal emergency lighting requirements. So for our local area, we may wish to consider, obviously, it makes sense, doesn't it? We've got a longer battery time for that area because we may wish people, in our risk assessment, it's been identified that, look, we're going to let people sit in there for up to 2 hours, 2.5 hours, excuse me, to see if the power comes back on. So that would be a classic example. This is a bit of an odd one. And again, just being put into this annex. Now, it was buried in the old standards, but it's been put out and into this annex, and it's more in your face now than it was. This is specific to care homes, or certainly that's the area that's been used as an example. Now, this is all to do with the fact that if you've got like a care home, you've got that sort of premises, you may wish to have the individual rooms as local areas or designated local areas, because in the event of an emergency, you may not wish to have these people outside the building where it's cold and it's wet and they're vulnerable. So it might be better then to have these areas designated local area. The people can stay in their rooms quite safely. They'd be in their rooms. And then should you need to evacuate, we can do so with fire wardens with specific head torches, can then escort them out once we're getting to the end of their local area lighting duration. Telecommand or inhibit circuits, effectively, this is all to do with ensuring that you've got a little bit extra in your you're conserving power in a portion of your battery so that we need to, or we could use it in the event of an emergency. Telecommand, obviously, you would do that remotely, and inhibit circuits potentially so that we've got that ability. If there's nobody in the building, for instance, you could have the ability to turn off your emergency lighting, as it were. It's that sort of thing. It's just trying to have some plan in place whereby you know that you've got, where you need it, some additional capacity in those areas. And again, we've sort of covered this. This is the shops or stores. This is the staff room scenario. It's one area that's specified where staff are safe for a duration of time, and where they can stay, they can perform their normal tasks in the event where they're waiting for the power to be restored. But anyway, that's Annex C, local area lighting. That's something new. Designers will need to consider the system duration, of course, the light intensity, the lux levels, testing procedures, and potential for it to increase in the areas. Of course, what I mean there is that, it's all very well if you've got your local area lighting and that's lit up beautifully, but if at some point then you decide to get out, you're going to need to have provisions so that people can see to do that. Okay. That is 1838 Whistle Stop Tour. 5266, released very recently at the end of October. There is a guidance note on our website with all the major changes in it. Now, just again as a pointer, lux levels, points of emphasis, specific area changes, they're all common to 5266 and 1838, but I've already covered them, so I'm not going to regurgitate the same information again. So we're going to go straight in, and again, similar flavour. It's the same point. They're really hammering it home. They're really in our face. It's, look, hey, risk assessment. The whole content here in 7.14 hasn't really changed about the location of power sources, but they've slipped in this because this is the point they're really trying to hammer home. Look, the fire risk assessment is the starting point here. It is the starting point. It's a legal requirement. This is the one that gives us the information for everything, pretty much. And it's the responsibility of the building owner or the responsible person. Now, this is something for just central safety power supply systems. Circuit integrity under fire conditions, of course. There are two significant additions to this section, and very similar to something that we saw earlier. In high-risk areas, emergency lighting luminaires should be wired alternatively or in another arrangement from at least two separate circuits. And it's all to do with a redundancy or fault. And point number two, whatever the scenario, each circuit should not exceed 20 luminaires. Now that may be a bit more challenging in bigger installations, of course, but that is a requirement, section 8.2.1 for central safety power supply systems. This is just a sort of indicator really now that for the first time 5266 recognizes 7671, and it's nice. It's like, oh, thank goodness at last. This will come as no great surprise, but it's in there and I thought I'd mention it just because it is nice and it's sort of all part of our normal experience. It's just a pointer to when you're installing cables, we need to consider premature collapse as per 521.10.202 of BS 7671. It's something I'm sure we're all aware of, but it is included in here for the first time, and a welcome addition. Again, this is still for central safety power supply systems, and now tells us that the cables for these systems need to be identified by a common color or some other means. So it's a common color in the case of multi-core cables, and it tells you where every connection between conductors and between a conductor and equipment, such that they can be distinguished from other circuits. If you're going to use a different color core and it's going to be specific for that, no problem at all. Or you could also perform that via labeling. And that's pretty much all that 5266 brings to the party that is unique and that hasn't been covered in the other sections. Okay, 50172, some large changes here, so I'm going to crack straight into it here. This is the oldest of the three. This was released just over a year ago now. This one, though, has doubled in size. It's gone from, the old version was quite old, 2004, 16 pages. The new version is 32, literally doubled in size. But there is a guidance note on our website that has all the detail. Right, moving straight in there. Section 5.2, emergency escape lighting equipment. Couple of generic points here. First of all, this is for if you're doing additions really, or indeed as a generic point if you're the designer. All devices, it's sort of a bit obvious really, but it's there in black and white now. All devices must be compatible to ensure system functionality. You'd have thought that at a design point when you're doing the whole system, it's a bit easier, but it obviously covers if you're adding points, replacing points, bits here and there, we need to consider that it's compatible holistically for the whole system. It's not going to inadvertently affect anything else upstream. There are more details to it regarding rush current and all that sort of stuff. But anyway, 5.2. It says that for installation on our power supply can't be from a plug-in socket, and that all items need to be identified. The distribution board, the circuit, and the luminaire need to be identified. Now, this document smashes home handover requirements, verification in a major way. So I'm going to try and cover those off now. Handover documentation, I haven't included all the points here. It's section 6 in this document, but there is a lot of detail in here, and it's just to give you a bit of a flavor here. Schematic overview, we need a diagram. We need to have instructions about how to use the equipment, and we need to pass over any maintenance requirements for that equipment. We need to have a list of replacement parts. We need to have detailed drawings. And certainly we need to include our commissioning data and our certification. Loads and loads of detail here, but I'm just trying to hit some pertinent points. Otherwise, we'd be here to 3 o'clock. But it's section 6, handover documentation. Lots and lots of detail. Again, a consistent point, the requirement for maintenance. It's got to be done. And again, there's more and more requirement as we know. It's coming at us from all angles with regard to this competence, isn't it? And here it is again. Inspection personnel must be qualified according to the relevant standards, and they must be competent. We're seeing it all over the place now. Gone are the days where you could do a qualification in 1974 and still be deemed competent without any training or continued development. Till now, it's not like that anymore, as we know, and I won't labour the point, but that is in there. It is the duly authorised person who is responsible for overseeing maintenance and managing the logbook. It's their responsibility, not ours, and it's important I just highlight that point. They have an obligation to do that. With regard to the logbook, there's plenty of detail in here. Now, it's much more in your face than it was before. It's actually been pulled out and put into a new section. The content shouldn't come as a surprise because it was in section 6.3 of the old one. But all I'm highlighting here is that it's been pulled out into its own section now, and it's much more in your face. It's recognizing, look, we need a logbook. We need to have evidence that we're maintaining. We need to have evidence that we're verifying, etc., etc. There's plenty of detail, section 7. Now, verification. 50172 has gone pretty big with this section. It's new section and with a distinct pointer towards verification. Verification is something that we shouldn't be new to us. It's a requirement, isn't it? Under the Brown Book, under 7671, we all know that initial visual inspection, initial verification is not new to us, but it's new to this. Certainly the in-your-face requirements. The word verification wasn't even in the old standard. So here it is now, and quite clear, 2 sections. We need to do a visual inspection once we've installed our system to make sure that it meets our design specification. Everything's in the right place. They're illuminated, they're clear, they're not obscured, etc. And then once we've done that, we need to activate the emergency lighting, and we need to verify it again, of course. Now, I'm sure this sort of element isn't a great surprise. It's sort of obvious to electricians, isn't it, that we need to do that. We need to test it to prove that it meets the requirements of the standard. That's what we've been doing for years. Of course, the really important thing here with the verification is that it meets the photometric requirements of the standards. Now, we are going to cover that in a sec. This one is new, 5-year verification, and I'm going to just hang on it for a couple of minutes. 5-year verification is new, and it's mentioned in all 3 standards. And the point is that we need to, every so often, we need to verify. We need to prove that our system is working as we want it to work. Now, it's quite clear in the standards that it must meet the system design requirements. It's quite clear about that. But the problem is, of course, as we know, you're probably not going to have the initial design data, in which case you default to the requirements of the latest standard. Now, with regard to this 5-year verification thing, there would be an assumption to sort of pair it with an EICR type thing. Now, whilst there are loads of similarities, this is not a pass or a fail type thing. We're not issuing a certificate that says unsatisfactory or satisfactory. It's not like that here. Think of this as a transfer of information to the responsible person. It is their responsibility to perform this function, and therefore it's their decision when this is performed. All we can do is verify that pass on that information for them. Your responsibility, this is now a new requirement. You need to consider this. We need to refer them back to their fire risk assessor possibly even insurance requirements. I'm sure you know what it's like. Insurance companies, they're always looking to worm out of something, aren't they? I'm sure this is going to come into insurance requirements for big buildings very shortly, if it hasn't already. Indeed, we're checking our requirements for our buildings at the moment. But it is going to be a requirement for the insurance. Certainly, it may well be in the fire risk assessment. But consider it like this. If the system is a new installation and it's got its initial design, then of course it's 5 years' time. If the system is old with no maintenance, really ideally as soon as possible. For old systems with evidence of maintenance, somewhere in between. All we can do is offer that information to our client. It's not a pass or fail thing, and we need to be careful about what sort of information we're partaking. It's not like you must do it. The requirement is theirs. Give them the pointer. It's their responsibility. Okay, on to Annex B. Right, loads of detail in Annex B about the type of equipment that we need to use when we're trying to verify emergency lighting systems. Gone are the days when you could go down to Screwfix and pick your £5 lux level meter, strap it to your, I don't know, whatever, and walk up and down a platform or whatever you were doing to try and take your lux level readings. It's not like that anymore. They need to be specific. They need to meet certain standards, and as you can see there, they need to have cosine corrections, calibration, temperature controlled. It's quite in depth. There's a lot of information in there, just for your information. Annex B. Now within Annex B, bizarrely, it also gives us this sort of information. Now this is information that we take on board when we're looking to measure our emergency lighting systems. Now, it's sort of in recognition really of stray lighting can be a problem when we're measuring it, when we're verifying it, our systems, as also potentially can be the quality of light during the duration of our test could also be a problem. So they offer 4 methods. I'm just going to sort of give you what the methods are. In Annex B, is a lot more detail, and there's some really quite complex formulas in there too. But essentially there are 4 methods. Method A, you would use this method if the stray light and emergency light is considered steady. So that's not a problem. You would pick your grids, which I'll cover in a second, and you measure away because you're happy that during the duration of your test, everything's consistent. There should be no worries. But method B is something that you would use if your emergency lighting fades over time. So for instance, and this is the example they use, if you've got fluorescent lamps in your devices, in your lamps, in your lamps, they can decrease. The light output decreases over the system duration, and therefore we may wish to make an allowance for that. You would generally use 2 meters in that respect, have one that's static and measures the decrease over time, and then your other meter would go around and measure your points, and you would take one away from the other. The formula is under method B in Annex B. Method C, the other way around, for when stray light changes, exactly the same sort of thing. Method D, for when they both change. That's in the information, all in Annex B. Lots of detail there. Incidentally, it's also in the guidance note on the website. Now, this is not as simple as you may initially think. It certainly wasn't as simple as I initially thought. When you start looking into this, this is actually quite complex, and I really would recommend that you try and use software to assist you if you have that facility, because how you measure or the measuring points that you use is determined by something called a measurement grid. And typically, and I don't know why, but there's no detail of measurement grids in the 3 standards that they're covering today. If you wish to, for that information, it's somewhere else. It's in 12464. This is for initial verification and periodic verification too. Illuminance grids, that's just, I've just snipped that information out just to sort of share with you. Look, it's this is the area we're getting into now. It's formula. It's really quite complex and really something that we should consider if we're able to use software if we can. See, this is an awful lot easier, of course, if the initial design information is available to us. But if it's not, when we're looking to verify, we're going down this road. So what you would look like, or what you probably would end up with, was something like this. And this is just a generic grid. You know, it's literally is a grid system. This is for obviously for open areas. This is for larger areas. And we would have a grid system like this. But there is a little bit of light at the end of the tunnel, because the standard recognizes that, look, if you've got massive areas, this is going to take you forever. So there are a couple of options to us. You can, rather than measuring every single point, you can use the light calculations. This is, of course, you know, we're talking about initial verification. So you've done all your light calculations, you've got them to hand. If you're looking to verify the system with the measurements, we don't need to go through all the areas. All we do is we look at our light calculations. We know what we're going to need in that area, or what we're expecting in that area. If we then go and measure in that area and it's there or thereabouts, and that's consistent over the points you've measured, then that is sufficient. You only have to do a certain amount of points, not everything. For 5-year verification, the principle's the same, but it's an awful lot easier if you've got the initial verification information. So for instance, if you go to do your verification, your 5-year verification, and you've got the initial design data, you know where the grid points are, that's lovely. All you need to do then is select a selection. So as you can see on the screen there, should include a minimum of 10% of the measuring grids with a minimum of 5 points. So if you've got a really small premises and 10% would be 2 points, of course, you need to make sure you're measuring 5 points. For larger premises, it's a 10% of the grid points. So that's an awful lot easier than doing all of them. If that information is not available, then you have to default to the initial verification situation. But again, the same principle as we had before, but you're unable to, you won't have the initial design, actually thinking about it, you won't have the initial design information, will you? So we're back to illuminance grids verifying the points. Thankfully, the actual defined escape route is a little bit easier. You do have the option to do it as per the grids, or why would you? We've got table B1, which is an awful lot easier, and it gives you the sorry, it gives you the options. How long is our escape route? Sorry, excuse me. And a recommendation of how often we should measure. Excuse me. We should measure at least every other step. We need to confirm uniformity. But of course, when it comes to our measurements and our verification, it's not just the routes, it's not just the open areas, it's also our signs. The internally illuminated ones are an awful lot easier. There's no initial verification measurements required, as long as they conform to a certain standard. If you have, sorry, excuse me. If you have these lights, 5-year verification just means you can use a selected number. You go around with your visual inspection, of course. You notice that a couple are not as bright as the others. In theory, this is what this is all about, and you select the dimmest areas just to conform they meet the requirements. Incidentally, I just forgot one other point. When it comes to initial verification and your measurements, if you have similar areas, and what they mean as similar areas, say for instance, you've got an office block and floor 36 is exactly the same layout as floor 37, exactly the same layout, exactly the same lighting design, exactly the same fittings. You only need to verify one floor. Okay, sorry, coming back, I just thought of that and it was important that I mentioned it. Okay, safety signs internally illuminated are a little bit easier than these ones. Each sign needs to be measured for externally illuminated pretty much on every occasion. There are some caveats in there, but it's section B6. This one's a bit interesting. We need to allow for measurement uncertainty, 10%. So in other words, if we need 1 lux or we're expecting 1 lux, we need to make sure that when we verify, we get 1.1 to allow for measurement uncertainty, even though we're using our calibrated cosine corrected category 2 lux level meters. Okay, we're nearly there. Just a couple of annexes left. Annex C. Think COVID here. This is all to do with considerations for the designer, really, if we're likely to encounter long periods of shutdown. It's just to highlight to the designer that, look, there are certain batteries that don't like this. And if you are going to disconnect the emergency lighting, we really ought not to have people in the building when we're doing that. And if we're going to reoccupy these buildings that have been empty for a long time, then it's a good idea to check our emergency lighting system works and it's up to spec before we let people back in the building. Sort of makes sense, doesn't it? Okay, lastly, Annex D. This is a bit of an odd one for me because it sort of doesn't sit with the plan that I was talking about earlier. This is all to do with wiring systems, and you think, well, why isn't that actually in 5266? But anyway, hey, it's in Annex D for 50172. Covers off a few items that we should really already know. It's general wiring stuff, really, but it just reiterates a few points that wiring between the safety power source and main distribution board must be protected against short circuits and earth faults. Only one supply circuit per cable, unless they're auxiliary circuits, then you can share a cable effectively. Protected devices and conductor sizing must allow short circuit current to trigger disconnection within 5 seconds, and we must consider selectivity to ensure that in the event of a fault, we don't disrupt the entire installation. We just want it to localize wherever possible. Okay. What I've tried to do today is highlight the key changes and to signpost where you can get the information. I hope it's given you a bit of a flavour for the changes. But please, we do encourage you to consult the full documentation. It's really, really important that you do that, or certainly our guidance notes. The changes are significant, particularly to testing. There are some installation requirements, points of emphasis, special locations, not special locations, specific areas, sorry. But there are opportunities for us here, definitely opportunities. Be aware of the legislation, be aware of the legislation, if only to protect yourself, to have that information that you partake and you pass on to your client so they know their responsibility. I know what it's like. They're very keen to shoulder that onto somebody else. There are loads of resources available to you. There are guidance notes for every single one of these documents that we've spoken about today, as well as an overall one that covers all 3. All our editable certs for you to use have been updated to the latest 31st of October 5266 version. So all the changes that are in there are now in here. And we've also now got a logbook template for you to use. Again, downloadable, editable for you to use. As well as the normal technical resources, of course. We have a YouTube channel. We have a technical helpline, email, technical helpline number. Oh, you can see it's all on the screen there. Okay, now I'm assuming that Gary's been beavering away with questions and answers. I obviously can't see that. I'm going to share now the CPD QR code and leave that on screen for you. But I'm done. Are there any questions? Is Gary even with us? Because I can't see at the moment.
Yes, thank you very much for that, Chris. You've summed up those 3 standards really well in just under an hour, so thank you for that. And yes, Gary has been working hard responding to everyone's questions. I think he's pretty much got through them all. I don't doubt he's still typing away as we speak.
Thank you, Gary.
But I think we're going to leave it there for you, Chris. You've done enough for this session. But if anyone does have any further questions, of course, do just get in touch with the technical helpline and we can get back to you on those. This session has been recorded, and so we will upload it to ECA's YouTube channel, and it'll go on ECA's website later today. So feel free to refer to it back and share it with your team. If there's anything else from you, Chris.
No. Thank you, Gary. Thank you, Kat. Thank you to everybody attending today. I hope it didn't keep you too long. And I hope I gave you the information that you were after. But if not, at least I gave you hopefully a signpost to where you can find more information. But don't hesitate to contact us. We're here to help and support wherever we can. Yeah, thank you.
Brilliant. Thank you very much, everyone. And thank you, Chris.
Thank you all.